Welcome to the section on Object-Orientated Programming. Object-Orientated Programming, or OOP as it is sometimes referred to, is about breaking down your code into objects. An object usually represents a thing that has some properties or maybe some methods. In Microsoft.NET, an object is synonymous with a class. In other words, when you create an object, you would create a class. Because of this, classes and objects are often used interchangeably within the context of Microsoft.NET applications and in Visual Studio. A property of an object is usually a bit of data, for example, a person's name or a product sale amount. Methods are actions that may affect the data of that object in some way. For example, an account action might have a payment method that decreases the balance property. The idea is that everything in software is essentially just a collection of things that all interact with each other. Sometimes these things are representations of real-world objects, for example, customer, product or account. If in your program, if a customer buys a product, it can cause the account object to change, i.e. the outstanding balance might increase. Sometimes these things are more abstract representations of functionality. So for example, you might have a stock manager object, and this is responsible for acting on various other objects, for example, reducing the stock level of another object when certain other actions occur on them. Objects also have or implement certain characteristics. The main ones are encapsulation, polymorphism, and inheritance. Encapsulation is about ensuring an object groups together all the necessary properties and methods for that object. For example, a customer object might have a name and address field that relates to that particular customer, and you shouldn't need to query other objects or services. However, objects can contain other objects. So for example, you might have an address object that defines street, town and postcode, and the customer may have a property of address. In this way, the customer is known as a root object and the address is known as a leaf object. Inheritance is the ability of objects to extend other objects by gaining all the original object's base properties and then adding their own. For example, you might have a person base class and then a customer and supplier subclass that inherit from person. In this way, common properties and methods, for example an address and a name, can be built into the person base class, and specific properties and methods that only relate to the new type of object are only written to the new object. Therefore, the resultant object contains all the properties and methods of the base object and all the new methods and properties of your new object. Polymorphism is where two objects can have the same properties and methods but implement them differently internally. This is often achieved through the use of an interface. The interface would define the properties and methods, sometimes known as the signatures, and then each object would implement that interface accordingly. An example might be a simple calculator program. You would have a result object that has a single method called compute and that returns a number. The method will take in two inputs as numbers and then do something with them. For example, one version of the object might add the two together, another implementation of the object might subtract the numbers. Each of these different objects would implement an iResult interface, which basically says I'm going to return a number as an output and take in two numbers as inputs, and as long as the objects implement those methods and properties as defined, we can swap them in and out as we need. Let's run through some more examples of how and why we might use objects. Let's say in our application we're building an e-commerce site. As part of that, we're going to want to store and record product information. We're going to want to store and record customer information. Hopefully customers are going to be adding things to a basket, and then at the end of it we're going to be taking those products out of the basket and creating an order with them. Now somehow you need to get products into the basket when people add them to the basket, and so what we would then do is create another object called a basket service, and this basket service would be responsible for facilitating that. Similarly, once a user wants to actually place the order, we would have an order service that would take all the products out of the basket and put them into an order object. Finally, we might have an account base object, and then we would have customer and supplier objects. Because both customer and supplier both implement a lot of the same methods and properties, we would inherit them and implement the account object. So that's the theory of object-oriented programming. Let's now get into actually showing some real-world examples by creating a very basic program.